Using limit definition, find the slope of the tangent line for the given function at the specified point. Here we have a function f of x or y is equal to 1 over square root of x plus 1, and we're trying to find the slope at x equals 0. The definition of the slope of the tangent line for the function at x equal a is f prime of a is equal to limit h approaches 0, f of a plus h minus f of a over h. Since x equal to 0, we have to substitute 0 for a. So 0, 0, 0. Then this is going to be equal to f prime 0 is equal to limit h approaches 0, f 0 plus h, that's f of h, right? Minus f of 0 over h. Now let's find f of h and f of 0. Here, since f of x is equal to 1 over root x plus 1, f of h is equal to 1 over square root h plus 1, and f of 0 is equal to 1 over root 0 plus 1. So that is equal to 1. So f prime 0, that is equal to limit h approaches 0, denominator is h, numerator f of h, that's 1 over square root of h plus 1, minus f of 0, that's 1. Now if we simplify this expression by multiplying square root h plus 1, square root h plus 1, because of this denominator right here, then that's going to be equal to limit h approaches 0, numerator is going to be 1 minus square root of h plus 1, denominator h times the square root of h plus 1. Now we're going to rationalize this expression. So multiply 1 plus square root h plus 1, 1 plus square root h plus 1. So that is equal to limit h approaches 0. Numerator is 1 minus h plus 1, right? So that is equal to h. Denominator, we have h square root h plus 1 and 1 plus square root h plus 1, right? So h from numerator, h from denominator, it cancels out. And if we substitute 0 for h, then that's going to be equal to, I'm going to write right up here, 1 over square root of 1 times 1 plus square root of 1, right? So that is equal to 1/2. So slope of tangent line at x equals 0 is equal to 1/2.